is made up of around an astonishing 14,500 individual components.
Formula One cars? It's all about speed, precision, and unconventional technology. But how are they made? Since you are a fan of F1, this will be easy to imagine. So, for a second, picture the roar of engines, the blur of cars racing past, and the lightning-fast pit stops that can decide the outcome of a race. However, behind all of that is something even more interesting, and that is the place where these billion-dollar machines are built. Today, we are taking you inside an F1 factory, so fix your seatbelt and let's race in.
Teams produce a new one every year, and although each design is unique,
Formula One has advanced from its early days when race cars were little more than advanced or modified road vehicles. What started as a raw competition of speed and driver skill has transformed into a billion-dollar industry where every fraction of a second counts. Today's F1 cars are not just fast, they are technological marvels built with the same precision as spacecraft and fighter jets. Consequently, the cost of creating these machines has skyrocketed, making them some of the most expensive race cars in the world. But what exactly makes an F1 car so costly? One of the biggest factors is materials. Unlike regular cars, which are mostly made of steel and aluminum, F1 cars are built using ultra-lightweight, high-strength materials like carbon fiber and titanium. Carbon fiber alone is incredibly expensive, but its strength-to-weight ratio is unmatched, allowing these cars to be fast while remaining safe. Then, the research and development goes into every single component. Teams spend hundreds of millions of dollars every season testing, refining, and improving their designs. Even a tiny aerodynamic adjustment can mean the difference between winning and losing, so engineers constantly push the limits. Aerodynamics is another major reason why these cars cost so much. Every F1 car is designed to cut through the air as efficiently as possible to create maximum downforce without unnecessary drag. This means teams use wind tunnels, computer simulations, and endless testing to refine the car's shape. The front and rear wings, barge boards, and even the tiniest winglets are all carefully designed to ensure the car sticks to the track while maintaining high speeds. Then there's the engine. An F1 power unit is one of the most advanced engines in the world because it combines turbocharging with hybrid technology. These engines are built to be lightweight, powerful, and incredibly efficient. However, they also cost a fortune to develop and maintain. An F1 engine alone can cost over $10 million, and teams are only allowed a limited number of engines per season. They get penalties if they use too many, which can cost them a race. Also, let's not forget the exclusive technology used in these cars. Many F1 innovations eventually become road cars, but they appear years ahead of mainstream adoption in F1. These cars are packed with futuristic tech, from brake-by-wire systems to energy recovery units. One of the most fascinating pieces of technology is the steering wheel, which can cost over $50,000. If you think it's just for steering, it serves more purpose than that. It's a full-on command center that controls everything from engine modes to tire settings. Before we hit the pedal on the step-by-step manufacturing process, make sure to rev up your engines by smashing that subscribe button and zooming through the like button so you don't miss out on any future videos. Step 1. The first step is designing the car. It is important to know that every Formula One car on the racetrack starts as an idea, a vision of speed and perfection. But before a single part is built, the car exists only on a screen in the hands of some of the world's most brilliant engineers. In a high-tech design studio, specialists use advanced computer-aided design, which is mostly known as CAD software, to create digital blueprints of every single component from the shape of the chassis to the smallest aerodynamic winglet. Everything is designed with one goal in mind: maximizing performance on the track. Unlike road cars, which are built for comfort, safety, and fuel efficiency, an F1 car is designed purely for speed. Engineers focus on aerodynamics, weight reduction, and structural integrity to ensure the car can handle extreme forces at over 200 miles per hour. Every curve, every air vent, and every wing is shaped to reduce drag and increase downforce. This keeps the car fitted to the track while cutting through the air as efficiently as possible. Even a slight miscalculation in the design could cost a team valuable time in a race, so nothing is left to chance. The aerodynamics department plays an important role in this phase. Using computational fluid dynamics, teams spend thousands of hours simulating airflow over the car. This allows them to test different designs virtually before committing to physical models. The goal is to create a car that balances speed and stability and will ensure it performs well on different circuits. Once the basic design is in place, engineers move on to fine-tuning. Here, tiny adjustments can make a huge difference. Sometimes just a few millimeters of change in a front wing's angle can improve lap times. That's why teams constantly modify their designs, looking for any advantage. Even after the car is built, new bodywork and aerodynamic elements are introduced throughout the season based on race data and wind tunnel testing. The materials used in the car are also carefully considered at this stage. The chassis, for example, is made almost entirely of carbon fiber, an incredibly strong and lightweight material. This allows the car to be as light as possible while providing maximum protection to the driver in case of an accident. Every component must be designed to withstand the extreme conditions of an F1 race, from high-speed impacts to intense heat generated by the engine and brakes. Beyond performance, engineers also have to consider the strict regulations of the Fédération Internationale de l'Automobile. The governing body limits everything from car dimensions to fuel flow rates to ascertain that no team has an unfair advantage. This means designers must work within these restrictions while still pushing the boundaries of innovation. An interesting fact about this phase is that F1 teams sometimes design multiple versions of the same car. They create different aerodynamic packages for different circuits, meaning a car used in a race at Silverstone might have slight modifications compared to one used in Singapore. These adaptations ensure that the car is optimized for the specific demands of each track, whether it requires maximum speed on straights or better handling in tight corners. Step 2. If you think an F1 car is made of metal like a regular car, you have been living under a rock. One important step or stage in Formula 1 manufacturing is carbon fiber processing. It is a material that is so advanced that it is used in spacecraft and military jets. It's stronger than steel but lighter than aluminum, making it the perfect choice for building a car that needs to be both fast and safe. But turning raw carbon fiber into an F1 chassis is no simple task. It's a process that takes precision, patience, and sharp technology. Inside the factory, sheets of carbon fiber fabric arrive in massive rolls. At first glance, they look like ordinary woven cloth, but don't be fooled. These sheets will soon be transformed into an F1 car's strongest, lightest components. Engineers begin by carefully cutting the fabric into specific shapes and layering it piece by piece into molds. Each layer is strategically placed to maximize strength and flexibility in key areas. Some sections must withstand massive impact forces, while others must be as light as possible without compromising durability. Once the layers are set in place, they are treated with a special resin that bonds them together to create a rigid structure. But this is only the beginning. The real transformation happens in the autoclave, a high-tech oven that uses intense heat and pressure to bake the carbon fiber into its final form. This process, which can take hours, ensures that the material becomes rock solid while maintaining its incredibly low weight. The result is a chassis that can handle the extreme forces of an F1 race. When a car goes through tight corners at speeds over 180 miles per hour, the chassis experiences forces that would crush a normal road car. But thanks to carbon fiber, an F1 car remains stable, flexible, and most importantly, safe. One of the most expensive parts of an F1 car is its monocoque, that is, the one-piece tub that forms the central structure of the vehicle. The monocoque serves as the driver's safety cell and is designed to protect them in a crash. It must be incredibly strong yet lightweight because any extra weight will slow the car down. To produce a single F1 monocoque can cost over $700,000, and that's just one part of the car. But the use of carbon fiber doesn't stop at the chassis. Almost every component of an F1 car, from the front and rear wings to the brake ducts and suspension arms, is made using this super material. Engineers fine-tune the thickness and layering of carbon fiber in different areas to achieve the perfect balance between strength and weight. Even the smallest details matter. The bodywork is designed to be as thin as possible while holding up under extreme conditions. If you have ever seen an F1 car crash, you might have noticed how pieces of carbon fiber shatter on impact. That's intentional. The material is designed to break apart in a way that absorbs energy to keep the driver safer in high-speed accidents. The level of craftsmanship involved in making carbon fiber parts is fascinating. Every piece is hand-laid by skilled technicians to ensure the structure is flawless. Even the slightest imperfection could compromise performance or worse, safety. That's why each component undergoes strict quality control before being approved. Interestingly, despite its strength, carbon fiber is extremely delicate before processing. If you handle raw carbon fiber sheets without gloves, the oils from your skin can contaminate them, weakening the final structure. That's why factory workers wear special protective gear while handling these materials. In recent years, F1 teams have been experimenting with new variations of carbon fiber by blending it with other advanced composites to push the limits of performance even further. Some teams even use a technique called pre-preg carbon fiber, where the fabric is pre-soaked in resin before it's shaped to give even more precise control over the final product. At the end of the day, carbon fiber is the backbone of Formula 1. Without it, these cars wouldn't be able to achieve the speeds and agility that make them so thrilling to watch. But producing this super material is just one step in building an F1 car. Step 3. The next step is building and incorporating the speed. In Formula 1, speed isn't just about raw engine power, it's about how efficiently a car moves through the air. Every curve, every wing, and even the tiniest adjustment to a car's shape can make the difference between victory and defeat. That's why teams invest millions of dollars into aerodynamics to test their cars in state-of-the-art wind tunnels to ensure they cut through the air as smoothly as possible. At first glance, a wind tunnel might look like something from a science fiction movie. These high-tech facilities feature massive fans capable of generating winds that mimic real racing conditions. Inside, scale models or even full-size F1 cars are placed on rolling belts that simulate the movement of a track. Engineers coat the car with fluorescent paint or use smoke trails to study how air flows around every surface to identify areas of turbulence or drag. Drag is the enemy of speed. The more air resistance a car encounters, the slower it becomes. Eliminating drag isn't as simple as making a car sleek, but smooth downforce is just as crucial. Downforce is what keeps an F1 car glued to the track at high speeds to prevent it from sliding out of control in corners. To ensure this, engineers must find the perfect balance, as too little downforce could make the car lose grip, while too much would make it slow down on the straights. Every part of an F1 car is designed to manipulate airflow. The front and rear wings, for example, are not just for show. They direct air in a way that maximizes stability and speed. One of the most fascinating aspects of aerodynamics in F1 is how teams tailor their cars for different tracks. A circuit like Monza, known as the Temple of Speed, requires a low drag setup to maximize straight-line performance. Meanwhile, a track like Monaco, with its tight corners and slow-speed sections, demands high downforce for better grip. Believe it or not, teams adjust their aerodynamic setups for every race weekend by fine-tuning every wing, flap, and surface to match the unique demands of the circuit. Wind tunnel testing is just one part of the process. F1 teams also rely on computational fluid dynamics, a virtual wind tunnel that allows engineers to simulate air resistance and test new designs before even building physical prototypes. CFD has become a game changer as it helps teams to rapidly experiment with new aerodynamic concepts while staying within strict cost and development limits. Even with all these advancements, real-world testing is still essential. That's why teams conduct on-track aerodynamic tests during practice sessions to fit their cars with special sensors and flow-vis paint to gather data on how air interacts with the car at race speeds. These tests provide valuable insights that wind tunnels and computer simulations alone can't always capture. One of the most extreme examples of aerodynamics in action is the drag reduction system. This clever mechanism allows drivers to adjust their rear wing on straights to reduce drag and increase top speed when overtaking. It's a perfect example of how F1 teams push aerodynamics to the limit by finding ways to make their cars fast and adaptable. The cost of developing aerodynamics in F1 is unbelievable. Some top teams spend over $50 million annually on wind tunnel testing and CFD simulations alone. However, with the introduction of cost caps, teams must be more strategic to ensure every test and modification delivers maximum performance gains without exceeding budget limits. At the end of the day, aerodynamics is one of the biggest battlegrounds in Formula 1. A perfectly designed car can shave off tenths of a second per lap, an eternity in the racing world. Here, engineers hardly take breaks as they work tirelessly, knowing that even the smallest tweak could be between standing on the podium or finishing at the back of the grid. Step 4. Another very important setup in manufacturing Formula 1 cars is developing the power unit. If you are wondering what this is, it's a technological phenomenon that combines blistering speed with unmatched efficiency. Unlike regular car engines focusing on reliability and fuel economy, an F1 power unit is built purely for performance. It's a hybrid monster capable of producing over 1,000 horsepower that will push the car to speeds over 220 miles per hour while recovering energy from braking and exhaust heat. The engine itself is a 1.6-liter V turbocharged hybrid. At first, that might not sound impressive. After all, many road cars have larger engines. But what makes an F1 power unit extraordinary is the sheer level of engineering involved. These engines rev up to an astonishing 15,000 RPM, far beyond what any standard car can achieve. If you are still struggling to get this, just know that most road cars redline at around 6,000 RPM. Now, can you see the difference? The insane revolution allow the engine to generate immense power while maintaining optimal fuel efficiency. However, raw power alone isn't enough to dominate an F1 race. Modern F1 engines are also hybrid, incorporating electric energy recovery systems. These systems harvest energy that would otherwise be wasted and allow the car to gain extra power when needed. There are two main components to this system. First, the MGUK, that is, motor generator unit kinetic, recovers energy from braking. When a driver slams the brakes going into a corner, this system captures the kinetic energy and converts it into electrical energy, which is then stored in the car's battery. Later, when the driver accelerates out of a corner, this stored energy is deployed for an instant power boost to give the car extra speed at crucial moments. Second, the MGUH, motor generator unit heat, recovers energy from exhaust gases. Also, when an F1 engine runs, it produces incredible heat. Instead of letting that energy go to waste, the MGUH captures it and converts it into electricity, which can either be stored or used immediately to keep the turbocharger spinning to reduce turbo lag and maintain power delivery. Once this is done, what comes out is a power unit that is not only insanely powerful but also extremely efficient. Even though F1 cars can reach mind-blowing speeds, they do so while using impressively little fuel compared to older generations of race cars. Modern F1 engines are some of the most thermally efficient internal combustion engines ever created, converting over 50% of fuel energy into usable power. In contrast, most road car engines only manage around 30% efficiency. Building an F1 power unit is an incredibly complex process. Engineers work with rare and expensive materials such as carbon composites and titanium alloys to ensure the engine is both lightweight and durable. Even a single component failure can end a race, so every part undergoes extreme testing before it is deemed race ready. Precision is everything down to the last fraction of a millimeter. One of the biggest challenges in modern F1 engine development is reliability. Unlike in the past, when teams could use multiple engines throughout a season, current regulations limit each driver to just a few power units per year. If an engine breaks down, it can lead to serious penalties, so teams are forced to balance performance with longevity. Engineers must ensure these engines last multiple races while delivering maximum power, despite the complexity and cost, as each power unit costs around $10 million to produce. F1 engine technology has greatly impacted road cars. The hybrid systems developed in F1 have influenced hybrid supercars like the McLaren P1 and Ferrari SF90, which have done a lot to prove that racing innovations often trickle down into everyday vehicles. The power unit is, without a doubt, the heart of an F1 car. It's a masterpiece of engineering that combines power, efficiency, and sustainability into one incredible machine. When you hear the roar of an F1 engine on race day, you're listening to decades of research, countless hours of fine-tuning, and the very best that motorsport technology offers. Step 5. The final assembly is the last but no less important step. This is where engineers bring all the precision and high-speed efficiency they can offer. Unlike road cars, which are mass-produced in automated factories, an F1 car is essentially hand-built in a process that takes weeks of painstaking effort. The assembly begins with the monocoque, the one-piece carbon fiber chassis that forms the car's core structure. This ultra-lightweight yet incredibly strong frame houses the driver's cockpit, fuel tank, and key electronic systems. Every connection point must align perfectly, from the suspension to the aerodynamic elements. In case you don't know, there is no room for error error, even a misalignment of just 1 millimeter, could impact the car's performance and potentially cost the team valuable tenths of a second during a race. After that, the installation of the power unit, which is the heart of the machine, comes next. The high-performance hybrid engine, along with its energy recovery systems, is carefully mounted into the car's rear. Engineers work in sterile conditions to ensure no dust or debris enters the sensitive components. The power unit is connected to the complex cooling system, which regulates temperatures to prevent overheating during high-intensity racing. The gearbox, another engineering masterpiece, is fitted into the car. Since it is designed for seamless, lightning-fast gear changes, an F1 gearbox can shift gears in as little as 0.01 seconds, and that is even quicker than the blink of an eye. This ensures that the car maintains optimal acceleration and speed throughout the race. The suspension system is installed next and designed to provide maximum grip and stability at high speeds. Unlike in road cars, where suspension is built for comfort, F1 suspension is tuned for absolute performance to ensure the tires stay in contact with the track even under extreme cornering forces. Each component is made from lightweight titanium and carbon fiber to reduce weight while maintaining strength. The aerodynamic elements, including the front and rear wings, are carefully attached. These components are not just for show, they are precisely engineered to control airflow around the car, maximize downforce, and minimize drag. Inside the cockpit, the steering wheel is installed. This is a highly advanced control center that costs over half of $100,000. The wheel is covered in buttons, switches, and dials that allow drivers to adjust settings such as fuel mix, brake balance, and engine power while racing at over 200 miles per hour. The driver's custom molded seat is also fitted and designed to provide maximum comfort and support while enduring extreme G-forces. Every step of the assembly process is closely monitored, with engineers constantly checking to ensure everything is functioning perfectly. The car undergoes rigorous simulations and electronic diagnostics before turning on. Sensors are placed throughout the car to track everything from tire pressure to aerodynamic efficiency to ensure the vehicle performs exactly as expected. Once the car is fully assembled, it undergoes a series of final tests. Engineers conduct a fire-up procedure where the power unit is started for the first time inside the chassis. This allows them to check for any engine, cooling system, and electronics irregularities. The car is then placed on a rolling road, which is a high-tech testing platform that simulates real track conditions to measure its performance before it is transported to the racetrack. The entire assembly process is a race against time. Teams are constantly working on upgrades. This means new components often arrive just days before a race. In some cases, mechanics must rebuild the car from scratch overnight due to a crash or last-minute changes. The level of coordination required is jaw-dropping, as every specialist must perform their role with absolute precision to ensure the car is ready to compete. Formula 1 is often called the pinnacle of motorsport, but it comes with a huge price tag. Unlike traditional racing series, where teams operate on smaller budgets, F1 demands financial power on an entirely different level. Every aspect of running an F1 operation, from multi-million-dollar engines to the cost of flying an entire team across the globe, is an exercise in extreme spending. One of the biggest expenses is the power unit. A modern F1 hybrid engine costs over $20 million, and each team is allowed only a limited number of engines per season before facing penalties. These power units are simply wonders of engineering designed to be lightweight, incredibly efficient, and capable of producing over 1,000 horsepower. The development of these engines alone requires millions in research and testing. Another major cost is aerodynamics. The front wing of an F1 car is one of the most delicate and crucial parts because it is designed to generate downforce and manage airflow. These wings are not cheap, as each one can cost up to $500,000, and they frequently get damaged in wheel-to-wheel racing. A minor collision can lead to teams swapping out wings multiple times over a single race weekend. And like it or not, this is a massive expense. Then there's the tire budget. Formula 1 tires are not your typical road car tires. They are specially developed by Pirelli to provide the highest level of grip and performance. However, they wear out quickly due to the extreme forces on the track. An F1 team can spend over $12 million per season on tires alone as they go through multiple sets during practice, qualifying, and the race itself. Now, let's talk about logistics. The logistics of running a F1 team is another aspect that gulps money like a thirsty camel when it reaches the river. Unlike traditional sports, where teams play in home stadiums, F1 is a traveling circus. Teams must transport their entire operation, including cars, spare parts, tools, computers, and even hospitality setups to 23 different countries in a season. This involves a mix of air freight, sea freight, and massive trucks. Chartering planes to move these high-tech machines worldwide costs millions every year. Beyond just moving equipment, teams also have to transport hundreds of personnel, including engineers, mechanics, strategists, and media staff. Each individual requires flights, hotels, meals, and transportation at each race location. The logistics team must coordinate every detail to ensure everything arrives on time. Even training sessions for pit stops come with staggering costs. A modern F1 pit stop lasts just 2 seconds. But achieving that speed requires thousands of hours of practice. Teams use spare car parts, including wheels, tires, and suspension elements during training sessions, and replacing these parts regularly costs thousands of dollars per session. Sponsorship deals and prize money help offset some of these costs, but only the top teams thrive financially. Smaller teams struggle to keep up with the spending war, so budget caps were introduced recently to level the playing field. However, even with financial restrictions, running an F1 team remains one of the most expensive operations in sports. Formula 1 is often called the pinnacle of motorsport, but it comes with a huge price tag. Unlike traditional racing series, where teams operate on smaller budgets, F1 demands financial power on an entirely different level. Every aspect of running an F1 operation, from multi-million-dollar engines to the cost of flying an entire team across the globe, is an exercise in extreme spending. One of the biggest expenses is the power unit. A modern F1 hybrid engine costs over $20 million, and each team is allowed only a limited number of engines per season before facing penalties. These power units are simply wonders of engineering designed to be lightweight, incredibly efficient, and capable of producing over 1,000 horsepower. The development of these engines alone requires millions in research and testing. Another major cost is aerodynamics. The front wing of an F1 car is one of the most delicate and crucial parts because it is designed to generate downforce and manage airflow. These wings are not cheap, as each one can cost up to $500,000, and they frequently get damaged in wheel-to-wheel racing. A minor collision can lead to teams swapping out wings multiple times over a single race weekend, and like it or not, this is a massive expense. Then there's the tire budget. Formula 1 tires are not your typical road car tires. They are specially developed by Pirelli to provide the highest level of grip and performance. However, they wear out quickly due to the extreme forces on the track. An F1 team can spend over $12 million per season on tires alone as they go through multiple sets during practice, qualifying, and the race itself. Now, let's talk about logistics. The logistics of running a F1 team is another aspect that gulps money like a thirsty camel when it reaches the river. Unlike traditional sports, where teams play in home stadiums, F1 is a traveling circus. Teams must transport their entire operation, including cars, spare parts, tools, computers, and even hospitality setups, to 23 different countries in a season. This involves a mix of air freight, sea freight, and massive trucks. Chartering planes to move these high-tech machines worldwide costs millions every year. Beyond just moving equipment, teams also have to transport hundreds of personnel, including engineers, mechanics, strategists, and media staff. Each individual requires flights, hotels, meals, and transportation at each race location. The logistics team must coordinate every detail to ensure everything arrives on time. Even training sessions for pit stops come with staggering costs. A modern F1 pit stop lasts just 2 seconds, but achieving that speed requires thousands of hours of practice. Teams use spare car parts, including wheels, tires, and suspension elements during training sessions, and replacing these parts regularly costs thousands of dollars per session. Sponsorship deals and prize money help offset some of these costs, but only the top teams thrive financially. Smaller teams struggle to keep up with the spending war, so budget caps were introduced recently to level the playing field. However, even with financial restrictions, running an F1 team remains one of the most expensive operations in sports.
So that is, the next time you commend the speed and efficiency of a car, just know that a lot of work went into it. Now tell me, what part of the F1 manufacturing fascinates you the most? Why don't you borrow some horsepower from the F1 and race to the comments to drop your thoughts? If you enjoy this video, do well to like, share, and subscribe to this channel.